Hi there, this is Kristen Underwood, Research Associate Faculty Member at the Department of Civil and Environmental Engineering at UVM. This is a presentation that was originally given on February 5th of this year at the Starksboro Library in a meeting hosted by the Starksboro Conservation Commission. And Kate Kelly of the Lewis Creek Association has asked if I wouldn't mind recording the presentation again because there were folks that were not able to attend that meeting on February 5th. So in an effort to make this recording more widely available, or the presentation more widely available, doing this recording on later in February of the same year. In July 2024, Starksboro was one of several Vermont communities that experienced flooding impacts from the remnants of Hurricane Beryl. In this presentation, I'll share monitoring data that characterize the magnitude of that July event. I'll review the geology and land use conditions that led to flooding vulnerabilities and impacts, and I'll illustrate how floodwater access to conserved floodplains help to dissipate the energy of this flood and reduce downstream impacts. I'll also touch on various mitigation strategies that could be chosen to avoid or to lessen damages in future floods, including examples from within and outside of the Lewis Creek watershed. I'd like to also acknowledge the many students and the many students and colleagues that have worked with our research team at UVM to generate the data and the plots, some of the plots that you'll see in my slides. And this work has been made possible by grants from several state entities, from NGOs, and from federal agencies, including the U.S. Geological Survey, U.S. EPA, and others, and NOAA. Vermont was hit with floods on the same date in July 10th, 11th, in the past 2 years. And here's the rainfall distribution data for those events. We can see that the July 2023 flood on the left was a much more widespread event that impacted essentially the full state of Vermont. Both of these illustrations use the same color palette, and I want to draw your attention to those very light salmon colored areas that received between 5 and 7 inches of rain. In the 2023 event, most of that rainfall was concentrated on a north-south axis, kind of on the eastern slopes of the Green Mountains. Fewer parts of the state were impacted in July 2024, just several months ago. In that storm, impacts were focused along in kind of a west to east axis, stretching from Chittenden County and northern Addison County over to the St. Johnsbury in the Northeast Kingdom. Lewis Creek watershed was impacted more heavily in the 2024 event. And we can zoom in on this location of the Lewis Creek watershed here in red. And we see that generally between 5 and 7 inches of rain fell on the watershed, and that rainfall was pretty evenly distributed. In other words, it's not like one part of the watershed saw no rain or just a little rain while the rest saw 5 to 7 inches. That 5 to 7 inches was pretty evenly distributed across the watershed in July of 2024. Lewis Creek drains an 81 square mile area and discharges directly into Lake Champlain. And during an event like this, rainfall moves quickly to the river network, and runoff is generated through the river network, and we can actually measure that runoff. There's a stream flow gauge, in fact, down near the mouth of the watershed, just above the Route 7 gauge. If you were to park alongside Route 7 there and hop over the guardrail, scramble down the bank to the river, you'd see a little hut that looks something like this, not exactly like this one here. And this on the left, here's my cursor. So U.S. Geological Survey maintains stream gauges at several locations throughout Vermont and throughout the United States for that matter, and they happen to have a gauge at Route 7 in the Lewis Creek watershed. Here we are, or were, at the Starksboro Library in the upper part of the watershed. And we can see that the watershed itself drains an area that spans several towns, including Heinsberg and Charlotte in the north, Starksboro and Moncton, even a part of Bristol in the south. So for this Route 7 streamflow gauge, we can go online and extract data from this gauge, view data from this gauge, and this is a hydrograph, an example of the data that comes from these river gauges. And this is the record in particular for that week in July that spanned the July 2024 flood. And we can see that on the x-axis we have days, and on the y-axis is discharge in cubic feet per second. And the gauge at this station takes a measurement every 15 minutes, and from that data we're able to generate this hydrograph that helps us understand how discharge is changing over time and peaking at the height of the storm. And so this gauge measured 5,750 cubic feet per second as a maximum discharge during that July 2024 event. So just for context, it's kind of hard to imagine what 5,750 CFS or cubic feet per second represents. If we think about a standard backyard pool, an in-ground pool, they hold about 20,000 gallons of water. So this equates to about, or rather 5,750 cubic feet equates to about 40,000 gallons of water. So 2 pools per second passing by the gauge. Another way to think about that is 120 pools per minute passing by the gauge at the height of the storm, at the peak of the storm. This streamflow gauge has been active on the Lewis Creek for about 35 years, since the fall of 1990. And so we can actually look back at the historic record for this gauge to understand how the July flood ranked. What is the context of the July flood? So it looks, what we can see here are the maximum discharge recorded in any given year over the 35-year duration of record for this gauge. And we can see here that the July 11th storm at 5,750 CFS was the highest recorded discharge for this gauge over its entire 35 years of record. And it's bigger even than Tropical Storm Irene. In fact, for this watershed, Tropical Storm Irene in 2011 was not nearly as big as the spring flooding in that same year. April of 2011 was very wet, April and May, and we saw a flood in the Lewis Creek watershed that peaked on April 27th of that year. So the 2024 event was pretty high. The December 2023 event was also pretty high in this watershed. But these data are just for the 35 years of record that exist for the gauge. There's also historical evidence of similar impactful storms if you go back into the historic records. So here's a newspaper, the Rutland Daily Herald, in fact, from 1922, recording a flood in the Starksboro region. The 27 flood was the flood of record for many gauges prior to Irene or even prior to the 2023 July floods. In Starksboro, it looks like damages were modest during that 27 flood. But again, here's another event in 34, and probably the event that most folks of a certain age remember the most in the Starksboro region or in the Lewis Creek watershed as a whole was the 1938 flood, which caused quite a bit of damage in the Addison County region. So while we have a 35-year record, there have been historical floods that have impacted Lewis Creek, but maybe not to the degree that we saw in July of 2024. Here's the watershed. Let's focus for the moment on Starksboro and the impacts that your town experienced in the July 2024 flood. So on the right-hand side here is what we call a longitudinal profile of the main stem of the Lewis Creek, stretching from the headwaters down to the mouth, a distance of over 30 miles. So here in the headwaters, our elevations above mean sea level are quite high. And down here at the mouth of the river, we're about 95 feet in elevation above mean sea level. So this profile is not dissimilar from, I don't know, a hiking app that you might use that you want to understand how steep is the trail going to be all the way up to Mount Abe or some other mountainous destination. It helps us to better understand where in the watershed slopes are steeper and power is greater to erode the boundaries of the channel, and where in the watershed slopes are much more gentle and therefore stream power is less and erosion may be less of a concern. Here's Starksboro occupying the upper portion of the main stem where those slopes are quite a bit steeper. And I want to draw your attention to a couple key spots along this profile where we saw the most pronounced damages during the 2024 flood. And these are at these junctures where the channel goes from being narrowly confined by its valley walls and steep in gradient, and then transitions out into a broad valley where slopes are much more gentle and the river loses power to carry sediment and large woody debris, and therefore that material tends to drop out in the channel. And we call these junctures or junctions alluvial fans. And at these junctures or near these junctures, we tend to see erosion happening upstream and deposition happening downstream. So here we are in plan view. This is the vicinity of Ireland Road and Hillsborough Road. And on the right, you see erosion that was recorded by the UVM Spatial Analysis Lab drone flights along in the backyards of residences along Ireland Road. And actually, there were some mass failures just downstream of this site. And then immediately downstream or closely downstream, between Ireland Road here in the foreground and Hillsborough Road in the far off distance, we see deposition dominated processes where sand and gravel and even cobbles in some cases were deposited in splays along this alluvial fan surface. And large woody debris as well was deposited. That erosion upstream along Ireland Road interrupted or cut off access to upstream homes, as you all know, for several days. And downstream deposition tended to jam the channel at certain locations, like here and here just above the Hillsborough Road Bridge. And those caused what we call an avulsion, where the channel, the Lewis Creek channel, actually jumped its banks and chose an altogether different path, and persisted flowing in this path for several days. You can see, notice the date of this photo, again taken by the UVM Spatial Analysis Lab. This is a week or so after the flood, and waters are still persisting in this avulsed channel. So these kinds of depositional processes are occurring downstream of that transition from steep and narrowly confined to flatter and unconfined. And from Mother Nature's point of view, this is exactly what is supposed to happen at an alluvial fan. Alluvial fans form at these transitions from steep channels confined closely by their valley walls, where they transition out into a broad, relatively flat valley setting. And given that sudden decrease in slope and confinement, the channel loses power to transport sediment and debris, and we transition from erosion dominated in the upper reaches to deposition dominated at the fan. And the channel then switches back and forth across this valley in response to the sediment and debris blockages. And in fact, if you can see here in this view with my cursor, there's a small tributary here that eventually, further downstream off the page to the north, joins up with the main stem of the Lewis Creek. But in fact, this was probably the old path of the Lewis Creek at one time, many thousands of years ago. And over time, this channel would have switched back and forth across this alluvial fan. We can see this if we turn on the 1-foot contours here between Ireland Road and Hillsborough Road. You can see this kind of concentric pattern here of those topography lines. This is a classic alluvial fan setting. And these are very risky settings that involve sudden changes in channel configuration that are not well predicted by any computer model. These alluvial fans are hazardous during floods, as we saw here in Starksboro. And similar impacts happened at countless other alluvial fan locations around the state in July, including Pingree Flats in Plymouth on the Black River, or the village of Plainfield on the Great Brook tributary where it joins the Winooski. And it happened in similar settings here in Starksboro. So for example, here at the base of States Prison Hollow, the creek jumped its banks and flowed across the road, bypassing the bridge at States Prison Hollow Road Extension. And in so doing, the river took a similar path as it did in the 1938 flood. Essentially, it rather than follow the channel here along States Prison Hollow Road under the bridge and across along the far side of the valley here, floodwaters just cut a path right across. And we know that this was documented in the 38 flood as well. These floodwaters carried away a car and turned a home 90 degrees off its foundation. We can see this from the imagery. So on the left here, we have a photograph taken in 2022. And on the right, we have imagery from the UVM SAL's drone taken on the 17th, just a week after the flood. Here's the car that got moved from the driveway and carried downstream during the flood. And here's the home that was rotated essentially 90 degrees off its foundation. So very powerful floodwaters. And again, they move in unpredictable ways at these alluvial fan settings in flood events. And that makes these locations pretty risky and vulnerable in flooding events. We also saw a similar occurrence at the Lazy Brook Mobile Home Park in the very northern corner of Starksboro, where debris clogged behind the Sugar House Lane Bridge right here. And as a result, the Hollow Brook, which travels down through this narrow riparian buffer, jumped its banks and flowed behind this home, ramped debris and floodwaters up against the upstream side of this home and completely surrounded the skirt and foundation of this home, and then proceeded to erode much of the access road to the mobile home park as well as much of Sugar House Lane. This particular location is on a drainage divide between Lewis Creek to the or Hollow Brook of the Lewis Creek to the west, southwest, that would be, and then off toward Huntington to the northeast. And so we saw evidence of sediment being carried in both directions here. These impacts have been very serious for the households who have been affected. And there were other losses in the watershed, including washouts of the Freedom Acres culvert and substantial losses at the Lewis Creek Farm. But I also want to tell the story of resilience in other parts of the town and other parts of the watershed where extensive wetlands and well-functioning floodplains that I've circled here in orange have been restored and conserved over the years. And in this storm event, they helped to attenuate or lessen the flooding impacts for downstream neighbors. So floodplains like those at the Coda Ball Fields, where floodwaters rose to more than 4 feet above the floodplain during the wee hours of July 11th. Floodplains like those at the Cobble Creek Nursery, where Kaylin Padua was able to kayak around their property at the height of the storm. Even narrower floodplains like we saw above Silver Street were filled to capacity and helped to attenuate flows. Floodplains below Baldwin Street crossing at the Baldwin farm, where lands had been conserved several years ago through the Vermont Land Trust. And floodplains above Quinlan Covered Bridge in that vicinity. These filled as waters overtopped the road in several locations and filled the valley with floodwaters. Some of you may recall that this was a site where Marty Illick was instrumental in working with the town of Charlotte to think about or plan for this exact kind of overtopping in a flood event, which in all likelihood spared the Quinlan Covered Bridge at this location. If we had instead tried to deepen the channel here, raise berms along the channel in order to force water to stay in the channel, in all likelihood, that water would have been directed at and damaged or destroyed the Quinlan Covered Bridge. But instead, if water had the ability, because water had the ability to pop over these roads and fill these floodplains in an expansive way, that decreased the power of those floodwaters and decreased the stage of those floodwaters at the bridge itself, and probably spared the bridge. Here's just a photo view of those floodwaters overtopping the road. And you'll note that hardly any, I don't recall hearing of any reports where this road was damaged to any great degree. In fact, it recovered quite nicely, despite those floodwaters overtopping. Below that location, also floodplains along the reach between North Ferrisburg Village and the Route 7 gauge filled with floodwaters. And even downstream at Greenbush Road for several hours on the morning of the 11th of July, floodwaters were able to slowly overtop the road here and slowly drain back into the river. And all of these connected and well-functioning floodplains served to reduce the peak flooding in the lower part of the watershed. And I'll talk for a minute about how we determined that. So as you recall, I mentioned that we have a Route 7 gauge, a USGS gauge that's measuring stage and discharge of the river at 15-minute intervals continuously. And this data is sent up to the web via satellite, and you can link to these sites um, and look for this data if you like. The peak of the flood of July 10th, 11th, 2024 was determined to be about a 50-year storm size. What that means is that it had a 1 in 50 chance. So in any given year, a 50-year storm is a size of storm that has a 1 in 50 chance of occurring in that year. We don't have gauges elsewhere on the river, but we do have sensors. Our UVM team has deployed sensors at the Coda ball fields at a few locations, one near the suspension bridge and one near what we call the Farmers Bridge, just upstream of there. And we have some sensors deployed as part of a different study in several several floodplains along the main stem as part of a habitat study. And from those sensors and from photographs taken just in the hours and days after the flood, we're able to piece together an after the fact estimate of the peak flood discharge at two locations, one at Coda Ball Fields here, and one along the Lewis Creek Road near the Turkey Lane crossing, where we were able to do what's called an indirect discharge measurement. So that's what these blue stars indicate. They're not actual gauges where we're measuring stage on a 15-minute frequency. These are locations where we were able to make lots of observations of high water marks that occurred during the event and calculate indirectly after the fact the peak discharge that was experienced at those locations. And from our calculations and based on regional regressions, we can equate the discharge that we calculated here to a 500-year storm at Coda Ball Fields and a 100-year storm experienced at Turkey Lane, Lewis Creek Road crossing. So importantly, that shows that for a watershed that received generally similar rainfall, we had a very high magnitude of flood experienced up in Starksboro that was attenuated or lessened as the flood wave traveled down the main stem to amount to only a 100-year flood at Turkey Lane, and by the time it reached all the way down here to Route 7, it was only a 50-year storm. And we believe that it's those well-functioning floodplains that were accessed during the flood that helped to attenuate that flood. So here's a little bit more about the kinds of evidence that we pull together to make that determination. We're out there in the hours and days after the event or even during the event, taking photographs, understanding where the floodwaters extended to, what were their high water marks. We have a bunch of sensors deployed, as I mentioned. This is an example of one. There's a sensor inside this PVC housing that has been bolted to a rock that we hope will remain stationary during even a big flood. And this on the right-hand side, this is an example of some of the sensor readings that we got from these sensors, including in orange here. This is a record of Site 31, which is actually near the suspension bridge at Coda Ball Fields, and we recorded 9 feet of water above that sensor. Now remember, the sensor is in the channel itself. It's at the bottom of the channel. So we have maybe 2, 3, 4 feet of channel bank above that before we get out into the floodplain, and then we had 4 or 5 feet of water in the floodplain above that. So that's what our sensor was telling us. We start to piece together other evidence, like these high water marks where vegetation has been trampled by the floods, and we actually survey that in. Here's the shadow of Stu Cabus, our master's student, who was out in the days after the flood with a GPS machine that would survey in the position and the elevation of these high water marks. We looked for debris caught in the backstops for the ball fields. As you see here, bits of leaves and other detritus that was caught. And we actually measured the elevation of those strand lines or debris lines as evidence of how high the floodwaters got. Many of you who were at the ball fields in the days after the flood probably saw the sand that accumulated on the pad here, but also we were looking for these subtle silt lines on the infrastructure that help us define high watermarks of this flooding event, surveyed in their position and their elevation. And so collectively, that information was brought together, added to our computer simulations of floods, and cross-section information was used as well at these locations to generate our estimates of the peak discharge experienced at these locations during the July floods. And that's how we came to understand that a 500-year flood occurred in the upper part of the watershed and decreased in magnitude with attenuation in floodplains to just a 50-year storm down at the Route 7 gauge. And that attenuation of the flood probably helped to prevent further damages in North Ferrisburgh, for example. With this view just upstream of the Old Hollow Road Bridge, and this view just downstream of the Old Hollow Road Bridge. Those spots experienced high water for sure, but they may have seen even higher water levels and greater stream powers, if not for the extensive access to floodplains that the floodwaters had further upstream in the watershed. And that's in large part due to a generation of restoration and conservation activities that have occurred in the watershed to protect those floodplains from further development. So in light of the impacts experienced in Lewis Creek watershed, how can we build back better? And I have just a few slides left to highlight some projects happening in the watershed as well as outside of the watershed. I think key, first and foremost, is avoidance strategies. And this is an example from the New Haven River in Bristol, where prior to the 1998 flood, which for us was a 500-year event, we had the inside of this meander bend was developed with 11 homes. And they were all evacuated during the 1998 flood. And thankfully, no one's life was lost, but all the homes were damaged or destroyed. And as a result of that event, and that disaster declaration, FEMA came in to offer buyouts for those 11 households, which they accepted. And the land reverted to town ownership under that project. It now represents 13 acres of a town park along 2,600 feet of river frontage. And we can see from this historical image how dynamic this section of river is. If we look back to the old photos from 42, this is where the river was at that time. To 63, it followed this path. To 2003, it followed this path. And even in years since 2003, we've seen the path of the river move considerably. as part of the deed restrictions that were in place as a result of these FEMA buyouts, no new structures can be built on this land, but it can be used for open space, recreational uses, and we, as a main objective of our town plan, we allow for floodwaters to overtop this area, and they did during the 2023 July flood. They overtopped this area, and even in the December 2023 floods, and previously in the Halloween storm of 2019, for example. So Bristol folks recreate and use this park quite a lot, but we also allow the river to overtop here, and in turn, that allows floodwaters to dissipate their energy and protect downstream properties. We enjoy many co-benefits of this buyout project, and that is the increased recreational access. We also use it as an educational site. Middlebury College is there. The high school uses it. It's a wildlife habitat corridor, and it also connects forest blocks to the east and west of this site. Similarly, we've done the same at a spot just a few miles upstream from Sycamore Park at the Saunders-Fuller parcel, where funding from Agency of Natural Resources, Agency of Ag, USDA, U.S. Fish and Wildlife, and our Bristol Conservation Reserve Fund, among many other public and private partners, helped us to conserve 54 acres of riverside lands along 3,800 feet of frontage. And again, these areas do not allow future development. However, they also, the acreage that was conserved, those protected lands offset minimum lot sizes on remaining lands to enable 2 additional building lots where we have affordable housing, or it's in the process of being developed. And so these are locations outside of the river corridor. They're outside of the FEMA floodway, and conservation of these lands helped to enable that as well. And again, we enjoy many other co-benefits, including improved water quality through the capture and storage of sediment nutrients, improved habitats, and this serves as an access for anglers and hikers and birders to the river. And finally, I'll just say that there are other projects that can be implemented and have been implemented in watersheds even as close by as the Upper La Platte River watershed. We see here on the left where a floodplain was lowered in order to create more storage for floodwaters. This is at the Beecher Hill site for those who are familiar. So there can be active restoration projects implemented as well that increase a river's connection to its floodplain to store more floodwaters, or expand crossing spans so that we're able to pass more sediment and large woody debris at crossing structures, and possibly open up flood chute reconnection to enable floodwaters a place to go during high water events. And this is a project site on the lower right here in Ripton, and I'd be glad to share those project details with folks if they're interested. So just a few additional ways to increase connectivity of our rivers and connection to floodplains, which have been shown to be really instrumental in attenuating floods in many locations. With that, I'll put up my contact information. I'm happy to reply to any emails for folks that have questions or would like more details on any of these projects. I appreciate your attention, and thanks for your time. See ya.